Students, this is a very quick intro to problem number 10, which I am now making pure extra credit. It is not required to complete your key questions. But this is a quick little intro, and then you are invited to work this problem through in person during warrior time or lunch or after school or open 1A, 1B. So let me just give you the background scenario. The scenario is this. People have been drawing accurate maps for centuries prior to the invention of any electronic or digital measurement. One might wonder how distances could be measured across terrain which cannot be directly measured. Says you and your quad mates, but it's now individual. You're part of a 1905 surveyors team charged with creating a 2-scale map of the Amazon River. Besides pencil and paper, you only have these 4 items. You have a protractor, a tape measure of approximately 100 feet, telescope, and an angular ruler and a tripod. Okay, this tape measure does not fit across the river. Let me explain the background here. So surveyor teams have been using these really simplistic tool. You can take it, you can see here the angled ruler, the telescope, the tripod, and they have been measuring indirectly distances. Now, why would you want to measure indirect distances? So we're talking about going across the river Amazon, and why you're not rowing a boat. Okay, you're not throwing a rock with string. Why would you want to indirectly measure it? Well, sometimes rivers can be deadly. Okay, between crocodiles or hippos, piranhas, there could be things in rivers which are deadly. I have friends from my church that all they do is build footbridges in Africa to connect villages to education and markets, because crossing various rivers, children would lose their life to flash floods, lose their life to dangerous animals every single year. So just by creating these footbridges, they are saving lives. But in order to create said footbridge, you need to know distances across things. So here is your scenario. You only have a hand protractor, a tape measure, angled ruler, telescope, and a tripod. These are your only tools. No digital equipment, no calculator, no laser to bounce off or anything. These techniques that are used in this problem are used even today. So here's the scenario. You have a river which is inaccessible, but you can find a landmark across and establish a point of reference. We're going to call that point R. You can measure anything along the riverbank and on land. You can measure here. You can measure angles, because you can stand with a tripod and you can measure this angle without getting your feet wet. You can measure a variety of angles without getting your feet wet. You cannot directly measure this. Noted the dotted line. Dotted line represents things you cannot directly measure. So your job is to figure out both a diagram and a mathematical way to find this distance across a river without getting your feet wet. If you must solve this problem in person, lunch, after school, warrior time. If you can come up with your own method and create a diagram and a summary, okay, that is accurate all by yourself, that's 5 points extra credit, but it has to be done in person on your own time. It takes about 15 to 20 minutes. If you come in during warrior time, lunch, after school, open 1A, 1B, and you give yourself 10, 15 minutes and you're like super stuck, I can make available to you a hint page, but then the maximum extra credit if you access the hint page is only 2 points. So here is your inaccessible river. You create a landmark, you can work along the water's edge, and you can measure anything on land. You do your right up here, use solid lines for things you can measure directly, dotted lines for things that you cannot measure directly.